Good morning. This is your stats sensei, Mr. Spensei, and we're going to go over the quiz. This will be a long video because I'm going to do all three problems in one video, so you may need to skip ahead to wherever you need to go. Um, so tumbleweed, commonly found in the western United States, is the dried structures of certain plants that are blown by the wind. Kochia, a type of plant that turns into tumbleweed at the end of the summer, is a problem for farmers because it takes nutrients away from the soil that would otherwise go to more beneficial plants. Scientists are concerned that Kochia plants resistant to the common herbicide glyphosate has changed over time. In 2014, 19.1% of 63 randomly selected plants were resistant to glyphosate. Well, this is important because this 19.1 is essentially our p hat. That's our first sample. So that's our p hat 1. And the 63 is our N1. Uh, 2017, 36.7% of 57 randomly selected plants were resistant to glyphosate. Well, this right here essentially becomes our p hat 2, and this is our N2. Okay, so we have p hat 1, N1, p hat 2, N2. Do the data provide convincing evidence at a level of alpha equal 0.05 that there has been a change in the proportion of all plants that are resistant to glyphosate? Well, I can immediately look and go, hey, there's definitely a change, but could that change happen by random chance alone is the question. Or what's the likelihood that it happened by random chance alone? Well, with that said, we need to set up a hypothesis test with an alpha level of 0.01. So P1 equals P2, or P2014 equals P2017. And they didn't say, in this case, there's a direction that says has been a change. Now, you had the same problem on the homework and it had a direction, but here we don't have a direction. So since we don't have a direction, we don't say less than or more than, where P1 does not equal P2. Extremely important to define our parameters. So let P1, and probably should say let out there, let P1 equal the true population proportion of plants that are glyphosate resistant in 2014. P2, the true population proportion of Kochia plants that are glyphosate resistant in 2017. All right, so 2014, 2017, no, they're not equal between the 2 years. Because this is a sample, we have to write random sample. Remember, if it's an experiment, we write random assignment. Given for both, most important that you include that both. I like to go ahead and include the sample sizes, 63 in 2014 and 57 in 2017. But all that was necessary is that, and you must have given for both, otherwise you lose points. It's reasonable to assume that the sample plants taken in 2017 were not influenced by the plants in 2014. The samples are independent. Or you could say both samples are independent. And that would be better. But you needed to let me know that both samples are independent because one did not influence the other. All right, we need to discuss the N is less than 10% condition, which is an independence condition to say that, hey, it's not really independent, but it's independent enough as long as it's less than 10%. So once again, because it's a random sample, we have to give that. If it had been an experiment, we would not have to give this condition. This condition is optional, because remember, if it's an experiment or says random assignment, we don't have to do it, or we are not to do it. But if it is a random sample, we have to do it. So the N is less than 10%. 63, because that was our sample size in 2014, times 10 is 630. Reasonable to assume that there are more than 630 Kochia plants in 2014. And we had to do it for the other one, 57 divided by 0.1. And reasonable to assume that there are at least 570 Kochia plants in 2017. And there's my statement for both of them. N is less than 10% of the population for both, and I could have placed it underneath, and that would have worked just as well. Number 4 is where I saw the greatest error. All right, this is where the biggest problem was on the conditions. Because this is a 2-sample hypothesis test, we have to use a different formula for checking normality. All right. So I'm going to talk about that real quickly, even though, and go a little bit off topic for a moment. If we're doing a one sample confidence interval, excuse me, one sample hypothesis test. So one sample hypothesis, we're going to go n times n1 times p1, and it has to be greater than or equal to 10, and n1 times q1 has to be greater than or equal to 10. That's for one sample hypothesis. For confidence interval, for CI, for confidence interval, it's n1 times p hat 1 has to be greater than or equal to 10. n1 times q hat 1 has to be greater than or equal to 10. And if we were using a two sample confidence interval, all right, so that's one sample, it'd be n1 p hat 1 greater than or equal to 10, n1 q hat 1 greater than or equal to 10, and n2 p hat 2 greater than or equal to 10, and n2 q hat 2 has to be greater than or equal to 10. Now, on these values, you could actually use, if they give you the x, the number of successes, you can compare those directly to 10. You can only do that on the confidence interval. Here on the hypothesis test, we have to use the sample size times the claimed proportion. Unfortunately, for a two sample, it's completely different. All right, and I saw this missed a lot. So two sample hypothesis, we're going to have to calculate p hat c. And we need to show our work for this, and p hat c follows the formula x1 plus x2 over n1 plus n2. Well, that will give us p hat c. Once we have p hat c, then we're going to have to do p hat n1 times p hat c has to be greater than or equal to 10. n1 q hat c has to be greater than or equal to 10, and n2 p hat c has to be greater than or equal to 10, and n2 q hat c also has to be greater than or equal to 10. So this time on the two sample hypothesis, we have to use the p hat c in order to make the comparison. If you didn't do that, you lost points. So I need to calculate p hat c. So p hat c in this case was x1 plus x2, but they didn't give us 12 and 21. So I needed to go in and calculate those. So x1 divided by 63, my sample size, equals 0.191. When I go about solving this, I get some decimal, 12.09. And if you use the decimal here, that's fine. Using the decimal of 12.09, that was great. And then over here, p hat 2 is x2 over n2. I plugged in while I went to solve it. So x2 over 57, that was my sample size, equals 0.367. When I multiply, I got a decimal of 20.909 or something like that. You could round it up to 21, or you could use the 20.909. And so there's my x1 and my n1. I plugged them in. I mean, my x1 is here over n1, so 12 over 63. My x2 over my n2, so 21 over 57. And I solved, and I get 0.275. So my sample size in 2014 times 0.275 equals this. That's greater than 10. And 63 times 1 minus that, there's my q hat, gives me almost 46, which is also greater than 10. Then we have n1 times p hat c, gives me 15.675. That's 2017. And the same thing in n2 times q hat c equals 0.415. Once again, I have to calculate p hat c to use up there. All right, so p hat c was used to make that comparison. then I need to make a statement. Both samples are large enough to use the normal approximation. Okay, so that takes care of the conditions. All right, and just so you know, the way the points were given on the quiz, this section right here was worth 6 points. The conditions themselves were worth 7 points. Then we needed to work the problem. All right, so I have my formula, p hat 1 minus p hat 2 over p hat q hat c over n1. And by the way, please remember this formula right there is given on the formula chart, straight off the formula chart. So I've written them down, and then I'm going to cross them out in case I made an error. I don't want to lose points for that. And so I have 0.91 minus 0.367. So there's p hat 1, p hat 2. And then I had to use QC, PC and QC. If you did not use that, you had it wrong. Again, that p hat c comes from here. All right. And there's my N1, p hat c, q hat c over N2. So when I go to the calculator, I'm going to go stat test, and I'm going to drop down to 2 proportion z test. And just to check this out, I have 0.191. Excuse me. I should have said our sample size was 63, so 63 times 0.191. Well, I get a decimal, all right? I cannot have a decimal there, so I'm just going to round it to the nearest value, which is 12. All right? And so that's also where my x1 value comes from. The next thing, it asked for, we have to do for 2017, which is 57 times 0.367. And once again, I get a decimal, so I round that, and I end up with 21. And there's 57. And then we needed a not equal to, because we said there was no difference. It said change, and it didn't give a direction. If you'll notice right there, we have our p-value, our z-statistic, and this right there, that point, the p hat right there is the p hat c. That's our combined. All right. So please notice, because this was a not equal to, I put a 2 times there. But if you'll also notice, the calculator gave me 0.0292. I did not have to double the p-value. All right, there's my z-statistic. I did not have to double the p-value. It did it for me automatically because I put in the not equal. I had a lot of people make the mistake of doubling the p-value, and they lost points for that. All right, so they gave me some different p-value. Okay, so here's my z-statistic, a 2 times in front. There's my p-value. I make a comparison. 0.0292 is greater than 0.01. So in that case, we're going to fail to reject. That's my decision. This computational part was also worth 7 points. Then we have our conclusion, which is also worth 7 points. So our p-value is 0.0292. We fail to reject the null. There is not sufficient evidence, and please use the word not. So fail is going to have the word not at alpha equal 0.01 to suggest that the true population proportion of cachea plants that are glyphosate resistant is in 2017 has changed from their 2014 levels or is different. All right, and probably been used better if I use the word is different, but has changed from 2014. That's what they had in the statement. All right, so that is our question number 1. I'm going to pause this video and get ready for question number 2, which will be continuation on this. Thank you. All right, this is scenario 2 from the quiz. In order to determine how a company wanted to spend their advertising budget, a survey organization was hired and conducted a telephone survey interviews in 2019 in which 1,009 randomly selected adults in the U.S. responded to the following question. At the present time, do you think television commercials are an effective way to promote a new product? Of the 1,009 adults surveyed, 676 responded yes. So that would be in 2019. So there's my sample size, and this is the number of respondents who said yes. So that's N1 and X1. In December 2022, 622 of 1,020 randomly selected adults in the United States had responded yes. So this gives me an X2 and an N2. Do the data provide convincing evidence that the proportion of adults in the United States who respond yes to the question has decreased? So from 2019, did we decrease to 2022? All conditions have been met and verified. So we don't need to discuss the conditions, but I'm probably going to anyway. So we need to run a hypothesis test at this point. And we say HO, P1 equals P2, 2014 equals 2017. Please remember, this could have been written just as easily. HO could have been written as P1 minus P2 equals 0. Then my alternative, 2014 is greater than 2017. So it could have been written HA P1 is greater than P2, excuse me, P1 minus P2 is greater than, not greater than or equal to, greater than 0. All right. So we need to define our parameter. P1 equals the true population proportion of adults who believe commercials are effective in 2019. P2 is the true population proportion of adults who believe commercials are effective in 2022. This part right up here was worth 6 points. We didn't have to do conditions. I'm going to talk about them real quickly. They were random samples, and that was given. We need to say that they're given for both. So I've given sample of 119 and 2022, or given samples or for both. Given. All right, but make sure that you respond to both. Independence, reasonable to assume that the samples are independent, as the 2019 response should not impact those in 2022. This is not an experiment. We have random samples, so we'd have to do the N is less than 10%. And back down here, which I discussed earlier in the video, because it's a hypothesis test, I would have had to use P hat C, which in this case, they gave us 676 is X1, 1,009 is N1, 622 X2, 1,020 N2. And I'd have to show it like this, P hat C, and that's what I did here. N times P hat C, N1 times Q hat C. N2 times P hat C, N2 times Q hat C. You have to use the P hat C and Q hat C for a hypothesis test. If you don't, you'll lose credit. But once again, this was not required for this question. Just wanted to go back over that. So the next thing, we needed to show our work. Well, to show my work, I have to have this right here. And remember, this formula is straight off the formula chart. So you can write it down if you can't remember it. So X1 over N1, X2 over N2, and I ended up getting a P hat C of approximately that. And here's my Q hat C. What they didn't give me was P hat 1 and P hat 2. Well, P hat 1 is 676 over 1,009, so that goes there. And P hat 2, 622 over 1,020, so that goes there. Now, I rounded those, but I probably should have carried them out to 4 decimal places. But if you rounded, that's fine as long as you show your work like this. So I've written my formula. P hat 1 minus P hat 2 over, and here's the PCQC over N1, PCQC over N2. Now I always cross this out because I may have made a mistake copying the formulas. So cross out your formulas. All right, so I'm going to go back to my calculator. Stat, test, 2 proportion z-test. X1 was 676, N1 1,009, X2 622, N2 1,020. It was greater than, we calculate, and sure enough, there's P hat 1, there's P hat 2, there's P hat C. We see that we have a Z statistic of 2.822, and it equals 0.023. Please notice I did not put a 2 times in front. We only have to put a 2 times in front if it's not equal. All right. So showing your work, that included all of this, was 7 points. My decision, well, 0.0023, they did not give me an alpha, so I'm going to assume 0.05. So our decision here is to reject the null. Our p-value is 0.0023. We reject the null. There is plenty of evidence at alpha equal 0.05 to suggest that the true population difference in proportion of adults who believe commercials are effective decreased from 2019 to 2022. So it definitely looks like it's gotten smaller as we went from 2019 to 2022. So that answers that part of the question. But then we had, what is the meaning of the p-value? And I was kind of disappointed that I had so many people mess this up, although we've gotten better about writing the definition of what p-value means. P-value is a probability that we'd observe a test statistic this extreme or more extreme given the null is true. You got some points for that, but that's not going to get you much. You have to put it in context. In this case, there's a 0.23% chance because our p-value was 0.0023. So that means we had a 0.23% chance that we would observe a sample like this, indicating that the true population proportion of adults who believe in commercials has decreased when in fact the proportion are the same. All right. So we are basically saying, hey, it looked like it decreased based on this. There's a 2.3% chance we get a test statistic like this extreme or more extreme, indicating a decrease when in fact it hasn't, when in fact it's remained the same. All right. And look, that says decreased. So probably this shows us that it decreased when in fact remained the same. So we restate HO, start with our alternative, then restate it as HO, given that HO is the fact. In the context, in this context, what type of error could have been committed and what might be the consequence? Well, the type of error, since we rejected the only type of error that could have been committed, doesn't mean we did it, but could have been committed as a type 1 error. All right, so I need this. That's my starting point. Then I need to put it in context. Well, if I believe that it's decreased, then the company may not use as much of their advertising budget for commercials, when in fact they were actually still effective. So I needed to say something along this line. In this case, the company would believe a TV commercial effectiveness had decreased, when in fact it had not, which would mean, here's the consequence, the company would spend advertising dollars on something other than TV commercials when in fact the commercials were still effective. All right, so they went to something that may or may not be effective, but we know when the commercials were still being effective. So please make sure you always put it in context, and just don't tell me what they believe. Some people tell me what they believe, but they didn't give me the context that said, hey, we're going to spend less money on TV commercials. All right, super important to do that. We had a lot of people get close. We had a lot of people do fine on that, but I don't know, maybe half did not give a good context with that. All right. Both of these were worth 7 points again. These are not going away. I can assure you that they will show up on your next test. All right, I'm going to pause this and get ready for the next problem. All right, this is scenario 3 for the quiz, and your stats sensei, Mr. Spensei, and this one was a confidence interval, one sample confidence interval. Each person in a random sample of 1,026 adults in the United States was asked the following question. Based on what you know about the Social Security system today, what would you like Congress and the president to do during the next year? The response choices and percentages selected are shown below. Then it says, find a 95% confidence interval for the proportion of all United States adults who would respond, make some major changes. All right, so make some major changes. Well, that gives us a p-hat of 39%. Given an interpretation of the confidence interval and an interpretation of the confidence level. This, when I say interpret the confidence interval, this right here is just your general conclusion, and this is in repeated sampling. And we had a sample size, in this case, of 1,026. So there's my N1. So first part, let P equal the true population proportion of U.S. adults who respond, make some major changes. Conditions. Simple random sample of 1,026. It was given. Because it's a sample, not an experiment, we have to give the N is less than 10%. If it's an experiment, a random assignment, we don't do that or we lose points. And we need to make sure our sample size was large enough. So 1,026 times 0.39 is approximately 400. It's greater than that, which is greater than 10. And 1,026 times 1 minus that is 626, which is also greater than 10. So the sample is large enough to use the normal approximation. So then I need to set up my formula. And by the way, at this point, I probably go ahead, I write down my formula, which I wrote down up here. Don't know why it's up there, but it is. Then I cross it out in case I made a mistake. Well, p hat is 39. We have p hat, that's 0.39. We have q hat, that's 1 minus that, and we have n1. So I've plugged in those values, but what I am missing is z star. So we're missing z star, and the way you get z star, second vars, inverse norm, parenthesis 1 minus 0.95, close parenthesis, divided by 2, mean is 0, standard deviation 1. We get a z star of about 1.96, which is what I wrote down here. So I've plugged in my values. So then I go to my calculator to run the test, and I'm going to run into a little bit of a hiccup. Stat test, scroll way down to 1 proportion, z interval, and I have a sample size. Well, first off, we don't have x, so I have to go 0.39, or excuse me, 1,026, because that was the sample size, times the p hat. That has to be a whole number, so I round up to 400. There's my sample size n1. There's my confidence level of 0.95, and there's my interval. So I have a lower bound of 0.36 and 0.419 as the upper bound. 39% will be exactly in the middle. So there's my p hat. That's really what we had. So 0.3600 to 0.4197. This right here, and by the way, we did not have to show we had to show the conditions. That was worth 7 points. On this one, showing your work was worth 6. So what are we? We are 95% confident the true population proportion of adults who would respond and make some major changes lies within this interval. Great. Next thing, they said, give an interpretation of the confidence level. Confidence level is the end repeated statement. Oh, by the way, that conclusion was worth 6 points. The repeated sampling, we would expect that our method would capture the true population proportion of adults who respond and make some major changes 95% of the time. All right. Our method is that awesome that if we did it over and over and over again, it would work 95% of the times, which means 5% of the time we have an error. It won't work. The advocate for leaving the system as it is now commented, based on this pool, only 39% of adults in the sample responded that they want some major changes to the system, while 41% said they want minor changes or none at all. Therefore, we should not change the system. Explain why this is technically correct is misleading. All right. Everything's technically correct, but we have a problem with this final statement. It says we should not change the system, when in fact, 19% want to completely overhaul it, and then some just want to make some major changes. If I combine that together, that means 58% wanted to make a whole lot of changes. So the system is misleading because the advocate implies that only 39% of adults want to significantly change the system, when in fact, 58%, I need to show where that comes from, want to make significant changes to the system. All right. So the problem here was that the fact that they did not include those who wanted to completely overhaul the system. I had people say, well, people say, oh, it's a valid comment because 41% laid within the interval. And it's like, well, yeah, but they left out people that wanted to make significant changes. And their statement was they should not change the system. So we need to make sure we read the question. This is a fairly simple one, but a lot of people miss points on this. This was worth 7 points. All right, lastly, sample size. Based on the proportion of people who want to make some major changes, in other words, the 39%, What size sample should be necessary to create a 99% confidence interval with a margin of error of no more than 2%? So please remember, p hat plus or minus z star, this part right here represents my margin of error. And so they said, okay, we want that part right there to equal 0.02. Well, in this particular case, we happen to have a p hat. Our p hat was 39%, so that was given to us. So that means we also have q hat. And what we're looking for is n. Well, I need a z star, and it needs to be based on 95%. So second vars, inverse norm. And I'm parenthesis 1 minus 0.99 divided by 2, mean of zero, standard deviation of 1, and I end up getting 2.576. All right, so I need to multiply these two values together, and I'm going to get something like this, and I'm going to go ahead and multiply them. So 0.39 times parenthesis 1 minus 0.39. I get 0.2379. Well, I need to square both sides. Well, I'm going to take this 0.02 and divide it by 2.576. 0.02 divided by 2.576. Oops. And then I need to square that because I need this radical to come off. So if I raise that to the second power, I get some really small number. And I'm going to take this 0.2379 that we calculated earlier and divide it by that small number. And I get 3943. Now, people are going to get different numbers depending on where they rounded, but I need to see whatever number you got. So right now I got 3943.56. So I would have seen n equals 3943.56. And if you wrote that, that's not going to get, that's going to lose half credit. I then need to see you write, so n equals 3944. All right, you need to make sure that you always round up. I don't care if this is 0.01, I don't care what it is. And the difference between the two and what I just did now is I carried less values for the 99%. Depending on how many values you carry for the 99%, you're going to get different numbers, but I need to see this. And then n equals 3,944. Make sure that this n is always a whole number. If you gave me a fractional number and otherwise shown your work correctly, you're only going to get half credit. All right, and this problem right here is worth 7 points. And you can expect a lot of these, or more than one of them, on the multiple choice. I don't remember for sure, but I wouldn't be surprised if there's one that works like this on the multiple choice as well, where we're working with a mean. So this is working with a proportion, this formula right here. This will be working with a mean, and that's probably going to show up on the multiple choice. All right, I hope this is really helpful to you all, and I hope your free response go well. I will see you all later. Thank you.